I'm Mark and this is my partner,
Gerson, and we will do some solving which talks about separable differentiation. So, let's proceed to our discussion.
The given equation is the quantity of x squared plus 1 dy is equal to xy dx. So the first thing that we need to do is combine all the terms with the same variables. So you need to divide x squared plus 1 and y in the equation. So that it will become antiderivative of 1 over y dy is equal to antiderivative of quantity of x over x squared plus 1 dx. Let us first solve for the antiderivative of the left side of the equation. We all know that if the exponent of the variable in the denominator is equal to 1, we will use the natural logarithm of absolute value of x plus c. So, the given equation, the antiderivative of the left side of the equation is the natural logarithm of absolute value of y plus c. Let us now move on to the right of the equation. In this situation, we cannot solve it normally. We will use substitution or integration by substitution. So, let u is equal to x squared plus 1. Most of the time, we are using the one with the highest exponent as u. Then, solve for the derivative of u. The derivative of it is du is equal to 2x dx. All we need is the value of dx so that we can substitute it in the original function. So we have dx is equal to 1 over 2x du. We let u equal to x squared plus 1. So the equation will be antiderivative of x over u dx. And we'll also substitute the value of dx in the function. So we will have a final function which is antiderivative of x over u times 1 over 2x du. After doing the substitution, solve for its antiderivative. We will not discuss it anymore because before going to separable differentiation, you must know how to solve for the antiderivative of a function. You can recall how by watching how I solved for its antiderivative. We can see that the exponent of the variable in the denominator is equal to 1. So, we will do the same thing here with the one we did in the left side. So, the function will become 1/2 times the natural logarithm of absolute value of u plus c. It is not done yet. You must substitute again the value of u. So the final equation is 1/2 times the natural logarithm of absolute value of x squared plus 1 plus c. The whole equation is the natural logarithm of the absolute value of y plus c is equal to 1/2 times the natural logarithm of the absolute value of x squared plus 1 plus c. Simplifying the whole equation, it will become the natural logarithm of the absolute value of y minus 1/2 times the natural logarithm of the absolute value of x squared plus 1 plus c is equal to 0. By simplifying it further, it will become 1/2 times the natural logarithm of the absolute value of y over x squared plus 1 plus c is equal to 0.
Our original equation is the antiderivative of xy dy is equal to the antiderivative of 3y squared plus 2 dx. We need to do is to combine all the terms with the same variable so that we can proceed in getting its antiderivative. So, let's do it. So, our final equation will be the antiderivative of y over 3y squared plus 2 dy is equal to the antiderivative of 1 over x dx. If this is the case, if the exponent of the denominator is equal to 1, we will use this format, the natural logarithm of the absolute value of x plus c. So that is the antiderivative of this one. Let's move to the left side of the equation. Here it's so very complex, so we can solve it normally. So we will use the u substitution. So we will let 3y squared plus 2 as our u. Then we need to solve for its derivative, which is 6y dy is equal to du. We need to get the value of dy so that we can substitute it in our equation here. So we can substitute it here. So the value of dy is 1 over 6y du. Next step is to change 3y squared plus 2 into u and changing dy with this one. So we will have the antiderivative of y over u times 1 over 6y du. Next is to simplify. So cancel and we will move the constant term to the left side of the integral sign. So we will have 1 over 6 times the antiderivative of 1 over u du. This is the same as this, so we will use the natural logarithm of x plus c, but we will use u. So we will have 1 over 6 times the natural logarithm of the absolute value of u plus c. And it is not done yet because it is u, so we need to change u with the one we let, so this one. So we will have 1 over 6 times the natural logarithm of 3y squared plus 2 plus c. So then we will have a final equation, which is 1 over 6 times the natural logarithm of the absolute value of 3y squared plus 2 plus c is equal to the natural logarithm of the absolute value of x plus c. Next is to move this to the left side of the equation. So we will have 1 over 6 times the natural logarithm of the absolute value of 3y squared plus 2 minus the natural logarithm of the absolute value of x plus c is equal to 0. By applying the laws of logarithm, we will have negative 5 over 6 times the natural logarithm of the absolute value of 3y squared plus 2 over x plus c is equal to 0. By simplifying it or making it positive, we will have 5 over 6 times the natural logarithm of the quantity of 3y squared plus 2 times x plus c is equal to 0.
Thank you guys.
And we hope that you've learned a lot from our discussion.
So thank you. God bless.
Once again, thank you.